welcome. The topic is Amazon Web Services, AWS Cloud, and DynamoDB. So, why AWS DynamoDB? So, what is the special feature of DynamoDB that makes to choose DynamoDB for the business? First, upload the administration buttons so that we don't need to maintain DB we don't need to maintain DynamoDB administration. Cloud will take care of it, and that offload the administration button and store and retrieve any amount of data and serve any level of request traffic. So Amazon Cloud will take care of scaling, horizontal scaling and vertical scaling when the traffic increases, and that these all administration related tasks all will be taken care by cloud. So on demand backup capability, so we can take a backup of entire database is by on demand. That option is provided to the users of Amazon cloud. And point in time recovery, and so Amazon cloud, it takes the image of that database in particular interval of time, and this can be restored at that system image point, and so that feature is providing to us. So point in recovery, so when there is a accidental updates has happened to the database, it can be recovered and to restore it from that image point. And high availability and durability, that the cloud always makes the DynamoDB high available and durability. So when to choose a DynamoDB? So when we have a business, and that based on the nature of the business, and we choose that DynamoDB. So that is the one of the point is that if the depending on the nature of the business, and so when business, the nature of the business and that particular business functionality, uh, so decided to make use of the cloud features, and it would be better to host the DynamoDB in cloud itself. So since AWS cloud is host the DynamoDB, and it would be better choice for to choose DynamoDB, so that DynamoDB can interact with other Amazon Web Services like authentication service and cloud functions and notification service. So it can easily communicate with the other cloud features, and that makes our application is more performant. So the other is, if you're that business, the nature of the business says that no, we don't need to maintain database servers, and data is not that much critical. We don't need to have that exclusive database servers for that business functionality, and definitely let's go for DynamoDB, which is hosted by Amazon Cloud. So use DynamoDB if you didn't have budget for dedicated database service. So that particular business, the nature of the business is forcing us that no, we don't need to have a dedicated exclusive database servers, and let's take this ready-made DynamoDB from AWS Cloud, and also that business is make use of that other features of the cloud, so that DynamoDB can communicate easily with other services of AWS Cloud. So when it comes to DynamoDB, and what is all about this DynamoDB? Is it a relational database, or which is what type of database it is? What type of storage management it does, and what type of presentation layer, and how we can provide queries that filtering criteria to database, and then how that it actually access the data on the how this storage management done by DynamoDB, and takes the data on the disk, and then presenting to the user. So how it is present to the user at end results, and that we are going to see that. And if you want to define it that, so that's no SQL data structure, and this is not a RDBMS, and this is no SQL data structure, and it is a dynamic database. So it's all node based, and it is not relational database. So that is how to define a database in a DynamoDB. If you want to define a database for a particular for group the related data, and we define one database. So how to define a database, and that database is we need to provide while creating a database, and we need to provide the database name. AWS cloud is exposed to us the naming convention, that is we call a database as a table in DynamoDB, like in RDBMS is we AWS cloud provided that that verb, and that syntax is that we call database as a table, and the table and table name, and every table will have a primary key, and that in AWS cloud and Dynamo terminology, and that we call as a partition key. So a table will have a partition key, and that's so all items in that table will have that unique value to that partition key. And secondary key is that if there is any records, the primary key and then composite key, this is the primary key plus, if primary key is duplicated, and then so we then all matching records, and that can be sorted by another key, and that that is a sorted key. So in DynamoDB, the data stores in partition. So when the items are when defined sort key, and items are sorted, and all items of that by one unique single party composition key, and that's stored in one partition, and that is something is internally DynamoDB manage the data storage management, and that's each record in database. That is, we define a table, and we define a primary key, that is partition key, and we can define a sort key. So each item and each record in database, so database is to relate the related we to is to group the related data. So database will have a set of records, and each record we call this a DynamoDB terminology, the call is item. So these are all keywords we need to use when we work with DynamoDB, and that is table, partition key, sorted key, and item. So so that each item is will have a n number of attributes, and that attributes not necessarily be the same, and all items in the database not necessarily as a same attributes, and this can be varied number of one item can have one some attributes, another item can have another attributes, and that attributes can be nested inside. So So that is that so attributes is not necessarily be the same number of attributes, it can be vary. So these are all a basic structure of DynamoDB. We create like a table and we give partition key, uh, and if you want that sorted key can be given, and then we call each record is item, and the item will have attributes. Attributes can be nested. This is just example of that. When you group that, when you store person details or employee details in a table, so each record is like this, and here it is primary key we defined as a person id, and that attribute of all items will should must be a unique, so that that is the here. And then here here we can notice that, and address attribute is not there in this first record, and so like that. So like that, it's not necessarily to have attributes, and this attributes can be nested inside up to 32 levels. So till now we have seen that we can access the database with a primary key, and or a composition key, that partition key plus sorted key. So database can be accessed in alternate index. We can define another index, and so that uh, we not necessary to use we can define a secondary index, so that database can be accessed with that secondary index rather than through primary partition key or sorted key. So that we can define a second index, and these are we have a set of DDL statements, and syntax is exposed by AWS cloud, and so we can follow that syntax, and we can create just like a table, and we can create a index, secondary index. So that second index, two type of secondary index we can create, that is that global second index and local secondary index. So when we create a secondary index, and we we access through primary key, and we define another sorted key. So we just change the sorted key, but while accessing through second index, it's as a composite key, and primary keys will be the same, and the secondary index is changed, and sorted key we can change. That is called local secondary index. And the global secondary index is that we don't use that uh, primary key and sorted key which is already defined for the database, and we use different primary key and different sorted key, so that we call as a global secondary index. So entire structure, database structure itself will looks different while accessing in secondary index, so that nodes, the relation between nodes will be changed, so entire that accessing mechanism internally changes when it is a database is accessed by secondary index. And these are all of briefly about how you define a database, and this is all about briefly about that. So let's see how to define a database. And we can go to the DynamoDB, and then tables, and create a table. And so here we give actually the AWS provides this console to define a table name, or we can define a table name programmatically. So we have a set of set of instructions, or set of syntax is exposed by AWS cloud, and we can define a table without a console, and we can define it programmatically too. So but here it is just I'm just showing in through console, and we can define a table, and we can define a partition key, and the type of the key can be a string or binary or number, and we can define a added sorted key, and that also same types. And so once these parameters, database name and key details is given, we can just create the table. So these are the tables which I just defined, and I'm taking to for this demo. And these are the posts. This is just related to jet news compose an android application that I taken as an example. And these are the post uh, database, and that database is so one more thing about Dynamo DB is stream enabled. So when database the record is added, when item is added or deleted and modified, so it generates the stream records, and that record can be accessed by our applications, and this record will be kept for 24 hours, and that can be accessed by our application. It is not like a real-time database like Google Firebase database. It is not at all a real-time database, and even but some of the features is enabled, that is a stream, and we can read that stream. It generates the stream records for that events, and add or delete or modify items, and we can just read and take and store it in one backup file, that backup database. We can use that stream records, and right now it is enabled is no. So that is table name and all details, and primary key are defined as a post id, and point in or recovery are disabled, and these are all just default parameters. And next is items, and these are the items I have added. There is a 10 records which is added, and we can this console provide us to filter this, and give the attribute name and the value. So we can add or delete we can add or delete and edit these actions, and can edit this. We can create like a UI here, and we can create a new record here, and with a different primary key. Otherwise we can just give it as a entire JSON, and then it will be inserted, and make sure that primary key is different, unique across the items. And this allow, and matrix, it shows that how many the hits on the database, and that's some matrix. And then capacity, we can define if something is related. So capacities is something is related to billing, and then we create index. We can create index itself here through console, um, and we create a global table, multi-region table. Now AWS organize this cloud and different regions, and we can create a table which is visible to the all regions, and which is visible to the multi regions. And backups, we can define the criteria of the backup, and the frequency. You can define a criteria of the backup. So that is and triggers, we can trigger a cloud function, that is lambda function, on the event of add or delete or modify items to the database. So these are all about the what we can do in the console regarding this table. And now we will go and how to add or modify or update item through application. So to access Amazon services from our Android application, we need to integrate that AWS cloud into our application, and set of procedures has been documented here, and we need to follow the step-by-step procedures to set up this project setup, and that we call it as integrate into our application, and then we need to install some node.js, and then we need to follow some certain steps, and so that we need to integrate, we need to run some npm comments in, and then we need to generates that some some files in this application, like under amplify. So for authentication, to access this DynamoDB, we need to, and that we need to add some libraries. So like some libraries we need to add, and that is authentication is taken care by Cognito, uh, that is Amazon Web Service, and we need to add this DynamoDB SDK libraries too. And once it is integrated, and we can access the database, and let's see directly go to that how to access a database. Whereas to access a database, Amazon Cloud provides various options, and one of these is higher order accessing option. So that higher order accessing option, we can define a table. We need to define a item of the table item structure. We need to define and attributes to the as a member variable of a class, and that class we need to annotate with the DynamoDB table, and then provide the table name, and provide the item partition key with annotation DynamoDB hash key, and sorted key also we can provide with the DynamoDB hash key and sorted key. So then attributes we can define with this annotation DynamoDB attribute annotation, and this DynamoDB attribute annotation can be nested, and so when it is nested, and it can be another as a defined as a class, and that class need to be annotated with the DynamoDB document, and it can be nested further, and that also defined as a DynamoDB document. So once it define this structure of item and class, and that we need to create instance of it, and then for that hash key partition key we need to pass that value, and for that value we so I just generalized I just kept it in a class, and then I created a class with JetNews DynamoDB, and the client we need to provide some details to access this DynamoDB. That details is authentication details, and authentication details are provided by Cognito Web Service and Amazon Web Service, and we need to provide some details, that is we need to create a user pool for that application. And when you create a user pool, and that user pool will have a set of users which have a similar access levels, and then for that user pool, and AWS creates identity pool ID, and which we use for giving access to the DynamoDB database, and so that these roles, and we have another AWS service that is called IAM Access Management. In that we have roles, and we can define a roles for our application for that particular user pool, and that is and we add a policies what type of access give to the particular user pool, and that I'm giving just full access to the DynamoDB database. We can have different type of user pools, and we can change the access level to the different group of different pool, and then that identity ID can be is mapped to here. And then so I have given that that pool ID, and pool ID we get from Cognito, and that Cognito service, and pool ID we, is Cognito service, and this is the pool ID which is defined for this, and we need to get that identity pool ID, and that user pool is mapped to one internally mapped to this identity, and that identity we need to give here. And so this is the pool name, and this is the ID which is generated for that particular user pool, and that we need to provide. And we need to two type of roles here: authenticated role, what type of access we have, and unauthenticated role, what type of access we can define in IAM. And those things need to be given here, and just pass that values to that provider. So once that provider once is given, and that to be passed to AWS client and DynamoDB client, and this client we need to pass to that, uh, and I pass there, and is set of so set of procedures which is exposed by AWS cloud, and we need to just provide that provider the client, and that client need to be passed to the DynamoDB client. Then DynamoDB will application gets access, and the user which who owns the who access the application will get access to the DynamoDB, and we need to create instance of that table item and provide that query. Here this is I have created a table instance and passed the value as a primary key, and that I pass to the query expression. And for the DynamoDB mapper we query, and then we need to pass that class of that table item, and then query expression. So it retrieves and maps back to it. It returns the list of items here, and that function we can have a list of items, can iterate through, get the details of item and all attributes items of for that item, it just store in that instance, and it written as item list, and we can access that. So how to update or delete, how to add a item, or update the database. So that we is got on the DynamoDB mapper, we need to call the save method on that, and provide that instance of this table item class, and for that instance of the class we can set the values to the all attributes of the class, including nested attributes. So here this post, I am getting the list of ports which is already defined by this just compose application, and each post I am iterating, I am getting the data and setting all the attributes of that post, and I am just calling save table item, so that it just saves on the database. And we already seen that DynamoDB just iterated over those data, and then all items are created here. These are all briefly about database, how to define a database, how to what is the syntax which is exposed to AWS cloud. And for our Android application or any application, iOS or web web application, we can integrate that AWS cloud into our application. Once it is integrated, we need to first sign in to the cloud, and once it is sign in, and that sign in identity pool details need to be provided as a DynamoDB client. Once on that client, we will get a mapper, and on the mapper we call the DynamoDB client, and then on that mapper we can execute the methods to retrieve or update the database. And we can that is through the class for that I table. And that's it, and this is all about DynamoDB.